Alright, so I'm recording my lesson so that I can put it on YouTube for you guys to review after. So let's go over the number system. Natural numbers are counting numbers like 1, 2, 3, 4, 5. What's the difference between natural numbers and whole numbers? Badar?
A whole number can include 0.
Right, the only difference is that it has a 0 as well. Are whole numbers also natural numbers? No. But are natural numbers also whole number? Yes. So natural numbers are part of whole numbers, but not the other way around. Right? What about integers? What's different with integers then? Okay, yeah, Badar?
Integers include negatives and positives.
Right, integers are also negatives. So it includes those. Rational and irrational are the ones that are tricky. These ones are pretty straightforward. But so rational, I think the easiest way to remember is if you can write a fraction using integers. So if you can write it as 2 over 3, that's a rational number. Negative 1 over 2, that's a rational number because 1 and 2, 2 and 3, these are all integers. Right? You can also have a decimal that ends. So 1.25, that's a terminating decimal. So that's also a rational number. Then what is irrational then? Irrational are numbers where you cannot write as a fraction or square root of numbers. So for example, if you use your calculator, root 2, square root 2, 1.41421356, it goes on forever. So these ones, numbers, decimals that go on forever, these are irrational numbers. Pi, as you guys know, 3.1413, that's also irrational. And then this one right here is not because it goes on forever. But what about 1 over 9? Is 1 over 9 rational or irrational? 1 over 9. Right. Who says it's rational? Put up your hand. Don't be shy. Okay, who says irrational? Put up your hand. Okay, who says I'm not sure? I did listen to you, but I'm just not sure. I'm not ignoring you. Okay, good. 1 over 9, let's try it. 1 divided by 9. It's a decimal that goes on forever, but I can still write it as a fraction of 2 integers. So which one can it be? It's rational because the decimal does go on forever, but it's repeating. So if it's a repeating decimal, then it's also a rational number. Okay, so that's why sometimes it's confusing. That's why I say if you can write it as a fraction of 2 integers, that's the easiest way to know that it's rational. Okay. So this diagram is really helpful in remembering what belongs to what set. Okay. So n stands for natural number. Natural numbers are also whole numbers, and they're also integers, and integers are also rational numbers. Okay, the letter Q out of the 26 alphabet, some mathematician decide to use the letter Q. I can totally see the letter Q in the word rational. Alright, and then instead of using alphabet, they decided to use a Q with a line on top to represent irrational numbers. Okay, and out of all of this, so all these numbers belong to the real number system. Right, so every single number that we work with in grade 9 is part of the real number system. What's the opposite of real number then? Anyone know? Opposite of real? Fake, okay, but a fancier word. Yeah, I heard it. Lucas? Imaginary, right. Imaginary numbers are square root negative numbers. Don't worry, you don't have to know it until grade 11. Yeah, you learn about imaginary numbers in grade 11. So for now, everything that we do will work with the real stuff. Okay, so let's try a few examples together. Let's work out the first page. Let's do this together. Okay, so 4.5. 4.5, what type of number is it? Participation. Kijun? Rational, good. Oh, sorry, oops, rational is a Q. Yeah, so be careful. Rational is the letter Q. And other than rational, what else does it belong into? Rational also belongs to the real number, right? So you actually do have to write both rational and real number. Okay, so that's why this is a very good good diagram to refer to. Okay, negative 3 over 8. What type of number is this? Jason? And? Yeah. No, not integer because it's a fraction. So rational numbers are also a part of real. Okay. Okay. 25. 1C. Maggie? Yep, natural. Alright, there's more. It's all, everything. You have to list everything.
Real.
Yeah.
Oh.
And?
Whole.
Yeah. And?
Integer.
Yeah.
Irrational.
Yeah, all this. Alright, because a natural number is also a whole number, it's also an integer, it's also a rational, and it's also a real number. So you have to list all those out. Okay, the number 0. Alexander? Perfect. A whole number, an integer, a rational, and also a real number. Alright, because 0 belongs to the whole number group. So all of this. Okay. Root 4. Square root 4. Okay, Jason? Uh-huh. And? Yeah. And all this. Huh, but miss, didn't you say a few minutes ago square root numbers are irrationals? But what is square root 4? Yeah. 2, right. If you square root, it's a perfect square number. So if you square root 2, it's actually, square root 4, it's actually 2. And 2 is a natural number. So yes, you do have to simplify. Okay. So this one was a little tricky, but you guys didn't get tricked. Alright. What about root 6 then? Can wait 2 more minutes. I'm almost done. Okay. Root 6. Isabel? Irrational. Irrational. What symbol is irrational again? Yeah.
Q with a line on the top.
Yeah, Q with a line on the top. Right. What else? Irrational is also part of? Real, right. Okay. And 2.111111, it repeats forever. Isabel?
Rational and real.
Sorry?
Rational.
Rational, right. If it repeats, it's rational. Whoops, and it's also real. Sorry, I wrote that too. See, out of 26 alphabet, I don't know why they choose rational for real and then Q for rational. Okay. 2.1. Terminating decimal. So Michelle. Oh, sorry. Maggie.
Rational and real.
Yep. Rational and real. Good. Okay. 1I. I'm trying to look at Lucas. Irrational and real. Good. Because it goes on forever and it's not repeating. Pi. Jenny?
Irrational.
And?
Real.
Good. And then lastly, negative 780. Negative numbers are Badar?
Natural, whole, and integer. And
Ooh.
real.
Can negative numbers be natural?
Yeah.
Oh. Natural numbers are only the counting numbers, so it can only be positive.
Integer and real.
Right, integer. And rational and real. Okay, so it will never be just I and R. If it's I, it has to also be Q. Okay, because the circle is within the other circle. Okay, so any questions so far? Okay, so there you go. That was the first lesson. Yeah, so quick. How long did I take? 11 minutes. Okay, so not bad for our first lesson. So for the rest of the class, I'm gonna get you guys to try these. Notice it says classwork / homework, which means if you don't finish, then it becomes homework. But if you finish, which you will definitely finish, because we are gonna take this up at the end of class, you can work on it, and then we'll take it up in about 20 minutes. If you're done this, you can go to Brightspace and go to quizzes and do this. So you can use your phone to do this, or I have 4 Chromebooks right there that you can use in class to complete it. So the 2 things in the next half an hour-ish. Okay, any questions? Yeah. Oh, great question. This one, the line on top means repeating. So 593, 593, 593, 593. Okay, so work on this. I'll come around the class to help. Just put up your hand if you have questions. Okay, so let's take up the work. 1A, who has an answer for me? Aisha. Rational or irrational? Rational, why? Right, perfect, because it's a whole. Remember, it's the letter Q for rational, all right, not R. What about 1B, root 4? Armin,
Rational.
because? What is root 4? What is root 4? Root 4 equals 2, right? So because it's actually a whole number when you calculate it, so that's why it's a rational. 2A, a decimal that goes on forever. Jalan. Irrational, good, because it goes on forever. 2B, Alexander?
Rational because it's repeating.
It's repeating. So some people were asking, but the top part is not repeating. That's okay. As long as the end repeats, it's rational. Okay. Number 3, give a number that would satisfy all these criteria. Okay, so your answers could vary because there's a dozen of possible answers. So Jonathan, 2. Yeah, as long as it's a counting number. 1, 2, 5, 17, all those are good. Okay, number 4, Adihi?
Yeah, 2.456 and it goes forever.
Okay, yeah, you could have a repeating decimal, or you can use pi. That's another example. Number 5, Alexander? Yeah, -2. So as long as it's a negative integer, then it's all good. All right, number 6, 3/4. List all that applies. Armin.
Real, rational, whole number, integer,
Ooh.
natural.
Okay, it's a fraction. So 6a. It's a fraction, so it can't be an integer. Alright, integers are whole numbers. So it can't be that. So it would have to only be. Anyone else? Yeah, Atihi?
Rational and real.
Rational and real. Right? Because the 3 and the 4, they're integers, but when you put it together as a fraction, then it's only rational. Alright, but what about the B, -12/4? Isabel?
Integer, rational, and real.
That's right, because -12/4 is actually just -3. And so it's an integer. If you take a look at this diagram right here, when it's an integer, it's also a rational number, it's also a real number. Okay, because the circle is within the circle, within the circle. 345, 345, 345. Abraham?
Real, not rational.
Perfect, because it's a repeating decimal. Good. What about the 7b? A number that goes on forever. Jason? Irrational. And real, right. Again, see, all of them are real. Okay, 8a, you could have a variety of answers. Give me one. Random one. Isabel?
Negative 0.6.
Yeah, -0.6. That's what I chose as well. Okay, 8b. Rational numbers with between them. Adihi?
Negative 5.76.
-5.76. Not just 6.
Sorry. Negative 5.76.
6.5, 6.1, 6.7. Yep, all good. And then 8c. Ibrahim? 3.55. Yep, 3.56, 5.57. All those are good. And then for number 9, you can see that if square root 25 is actually just 5. So 8 minus 5 is 3. So this will make B a rational number. The other two are decimals that go on forever with no pattern. So your answer for number 9 is that, A and C. So number 10, this diagram right here, what is this diagram called? There's a special name for these diagrams. I see a lot of new hands. Hey, Maggie.
Venn diagram.
Venn diagrams. EQAO will ask about Venn diagrams, so we'll do a few more practice on these, but know how Venn diagram works. I think you guys learned about Venn diagram in public school as well. Okay. So negative 0.462. What does it belong to? Maggie?
None of them.
None of them. So if it's none of them, you write it on the outside. Alright. You don't need to draw a separate circle or box or anything. Just write it on the outside. It will mean that it doesn't belong to either or. Negative 56. Leandro? Integers. Good, because it's a negative number. 735. Keijun? In the middle, that's right. If it's an integer and a whole number, you write it in between, right in the middle. 0.326. Michelle? Neither of them, so you write it on the outside. 8321. Adihi? Both, so in the middle. And last but not least, the number 0. Jalan? In the middle, right? Because it's an integer and a whole number, so you write it inside the middle. All right, awesome. So how many thought this lesson was easy? Okay. How many thought it was a little hard, but then I get it now? Okay, awesome. Those of you who still don't get it or still have trouble, remember you can go to the YouTube channel. I will be uploading this channel on there. And then don't forget to subscribe and like. Okay, you'll see this video uploaded soon.